Hi, thanks for checking out our channel. Here's going to be possibly a repair video on this particular unit. It's a Kencove EKD3. It's a little dual-powered AC/DC model, 3 joule output. This model, they make an EKD. Well, actually, Kencove doesn't make this thing. It's made by Power Wizard. Power Wizard makes a 1 joule, 3 joule, and a 5 joule that are in this configuration. This is the middle size unit, and I think it's called a PW3000XD is the Power Wizard equivalent. They just make this private label deal for Kencove. I think Kencove makes a lot of their own stuff. I think a lot of it's made by other places, private label contract stuff. But anyways, a note on it says he's actually got 3 units here. This one and 2 other models from other brands. Issue with the unit unknown to him. All 3 just stopped working. He wants me to bench test it and call him and do repairs if it's cost effective. So that's what we'll do. Well, first of all, I don't have the I'm gonna look in his box real quick, but I don't think he sent the cord for it so we can power it up, which I think I've got a cord here that will work. So let me go look in a box real quick to see if he sent the cord or not. Alright, the customer did not send the cord with it, which is fine. I've got this little pigtail here that I can plug in right there. And then this is it's an AC/DC model. It has a little wall wart that plugs into your wall, and that takes your 120 volt, turns it into about 13 volt DC. And then they got the 12 volt cord. So let me get my power supply here. I have my power supply set at 13 volts, so we'll hook on our leads here. Okay, no draw on my power supply. Let's hit the little power button here. Nothing. Okay, well, let's pull it apart here and see what we got going on. Ooh. Whenever he's installed at, see this residue here has come off this metal plates here, off this transformer. And that could be moisture. Well, it shows no life at all, so how old is this unit? Is there a date on this thing? Well, this is 042 something, so that is manufactured in April of 20 something, 2020, 2021, 22, 23, 24, 25. So not that old. We're in 2024, 2025 time frame. So, well, the first thing I want to do is check this capacitor. So it is a top wire and a bottom wire. I'm going to plug one of the wires so I can take it out of circuit. Looks like this takes a 16 microfarad 1000 volt capacitor. So we're going to check the capacitance of it. Put a meter on capacitance. And I'm going to test, there's no polarity to it, so we're going to test this wire to this wire. Should be, had it for a second, 13.7 out of 16, a little low. But not enough to where it won't run. So next thing I can do is I can check the primaries of the transformer, which is the input side, which is these 2 contacts here. It should be 0.1 to the 1 ohm. 0.2. So our issue is the board. So the primer, the transformers are all the same on how you test them when it comes to these electric fence boxes. They're just a closed loop primary, basically. If it was an open winding or a high resistance winding, then the board and capacitor, when they fire, they can't fire. Basically, it's too big of a resistance opening, and it can't fire that energy through it. So basically it's a closed loop to allow power to easily pass through the transformer when the board and capacitor discharge. And the ticking noise you hear on electric fence boxes comes from the transformer itself. When the energy is fired out of this, when it passes from the primary side to the secondary side, when it passes through, that's the click noise you hear. That's it passing through. That's on all electric fence boxes. Some people think it's a capacitor discharging. No, the capacitor's quiet. It doesn't make a noise. The board discharges and fires a capacitor, but it comes from the tick noise comes from the transformer itself. All right, we'll get these wires unplugged here in a minute, but I don't have all this memorized, which wire goes where, because we don't get these in all that often. They come in a handful of time a year, but I don't work on them every single day, so I always have to, once I do a few tests, I can usually narrow down where a problem's at. But a problem's in the board. I don't know why the board's failed. There's no schematics for it, so we'll test it. There's a big diode on there we can check. We can check this SCR, of course, and these capacitors probably aren't bad, but we'll check a few things if we can't figure out what the problem is with the board based on the little parts that we know what they are, because there is a lot of surface mount parts on there, and we're just going to have to replace the board with a new one. So let me go look through my stuff, see if I got a board for this model. Okay, there's the new board. So you can kind of look at all the crap they got going on with it. They got chips. They got a pretty thick conformal coating on this thing, with it being an indoor-outdoor unit. They try to help with water damage and corrosion and stuff like that, because these aren't a sealed unit. They do have a little foam, yeah, it's foam, not rubber, foam gasket runs around there, not sandwiches up against this little lip here, but, you know, moisture probably still can get inside. So you can see a lot of little components on there. You can't tell what half the little ones are, but let's pull this board out. Turn it over this way. Let's hopefully the conformal coating isn't getting away too much when we go to check the diode on there. That diode's used as a protection piece for the discharge side of the SCR. Oh, that's shorted out. Let's check this SCR. Alright, we got a bad SCR and a bad diode. Just checking on this one, just to compare. See, that one's not shorted. That one needs, you know, a good number. Yep. So, our problem's the SCR and the diode. Let's see if I can read. I got diodes, but see what kind of SCR this has got. See, it's got a real thick coating on there, and it's at such a bad angle, I can't hardly even read it. Well, I've got a bunch of different SCRs, but, you know, they're not all universal, especially when it comes to 12-volt stuff. I got this SCR here that we can stick in there. And then I've got a diode here. So I'm going to put these in there. And with this being a freaking double-sided soldered board, makes it even more wonderful to mess around with. Okay, so with this having all that, I don't know if this is going to solve our issue or not. It's definitely parts that are bad. So we can try to solder new ones on, and then hope, you know, put power back to it, see if it'll fire back up. But what we're going to probably have to do first, since there's a conformal coating on there, let me get my soldering iron, which is powered up. Let me find my solder. Where the hell did that stuff go? And what we'll do is we'll basically reflow the solder that's on the board, and that will at the same time basically burn off the solder. There's my solder. Or not burn, it burn off the coating that's on there. Make it a little easier to desolder. So add some solder to the tip there. Yeah, it's having a hell of a time. There it goes. Now it's burning through it. Okay, so we're burning as I'm reflowing. This is a real shoddy job. Whoever built this board. Okay, so let's clean the iron off. We'll take this solder wick. This is the good stuff. The good solder wick, not the cheaper stuff that doesn't. This stuff has like rosin flux stuff built into it, so it helps to helps the transfer heat and everything in the stuff, and it sucks the solder right off the board. You don't typically have to add extra flux to it unless you want. So, and I hardly ever have to. Now this is a double-sided soldered board, so there's solder on the front side and the back side. So I'm hoping we can pull enough of it off through the back side that it will pull the front side as well a little bit. And we can pull those parts off the board without it fighting us. See all that shininess, so that's the conformal coating getting hot and kind of liquefying. It's like a wax almost. Come on. Wires on the board keep trying to fighting against me, trying to turn the board. Okay, this is a board labeled which way the diode goes in. I think it is, but at least I got this board to reference if I need to. Okay, there's one side of the diode. Come on. Okay, the diode popped off. Let's see if we can get this SCR to... There's one leg. And that one's still stuck in there because it's got solder on the front side. So we got one leg left. It's still got just enough solder on it to hold me up. Now there could be more wrong than just these two parts. The parts like that I know what they are. I mean, there's a big resistor on there, which looks good, probably is good. Nope, it fell out. Good. Now we got to see if we can see what the number is on it. No, it's that waxy buildup is coming off, but I can barely read it. Oh, S8055R. So it's a 55, I believe S8055R. I think that's a 800 volt 55 amp. Something like that. It's actually, I might actually have that exact one. Because another brand uses that same one. Is this it? S80. No, that's not it. No, I don't think I've got the right one in stock. I mean, the exact one. I think because Zariba is another brand. They use that SCR on their 100 mile. But we can use this one. This will work just fine. It's a higher voltage. I think it's like 1200 volt. Okay, let's see. How does that go in there? Alright, hold on. One of the holes, that last hole that SCR fell out, there's still some solder in the hole, and I'm not going to be able to get the lead to go through there. Now it's on. Now it's back open. Okay, so looks like the SCR goes in this way. Oh, I bent the lead the wrong way. Get to kind of position them like that. But this one, the way it's set up, the middle way goes backwards. Like that. And then we'll put it in here. Come on. And then we'll take this diode, and there's a symbol on the board that tells me which way the diode goes in, which is nice. Can't see that big old resistor's in the way. Let me get. Come on, get in there. There we go. There's that. Sit there. Alright, so we'll add some solder to the tip there. Just making sure it looks good. Okay. Snip off the excess. Alright, let's plug this wire back in. I remember these boards always freaking fight me a little bit. Going back in here. Just like that. Look at this. Oh, it didn't fight me as bad. That time, sometimes installing those boards can be a bit of a pain. I'll turn the power supply off real quick. Let's plug this in here. Okay, power's on, power supply's on, just push the button. It's not going all the way to the very top though. Half power. Off. Yep, so that light does indeed turn on. Pulse all the way to the top there once. So at least we know the board's functional. Well, why isn't the top light lighting up? It clicks. Let's see what the output voltage is. We're getting 9,000 volts out of the thing. I don't quite understand why that top light's not clicking up. I mean, it drops down by a light or two on half power. Is it because the capacitor's a little low? Possibly. But what is it? 13.7 out of 16? That's what, 2.5 lower than full. I mean, it's not that far off. I've seen other brands with similar size, whatever, and it doesn't affect it that much. Let's see if I've got another capacitor I can stick in there for a second. Okay, I don't have, because we don't see a lot of these capacitors go bad on these units, and they don't come in all that often. So I've got a 20 microfarad capacitor, brand new, but it's a little bit different style. It doesn't have leads coming off of it. It's made to go onto a circuit board and solder it in, but I can solder some leads to it and plug it on to the board. And I'm just gonna make them kind of long. Tin the wire. Add some solder to here, tin this lead here. Hold them side by side and heat them both up together, and they'll blend together. Hold it until it cools down enough to harden up. Now I'm going to discharge the capacitor real fast. It may have a charge built up in it, and I don't want to get bit by it. I got this big resistor here. It's a 75 ohm, 300 watt capacitor or resistor across the two leads of the capacitor. That bleeds it off without that great big pop that comes from those capacitors sometimes. So it looks like it's the top one and the bottom one. Let's strip this back, crimp on some new female spade connectors. Come on. Let's get these leads over here just to get them out of the way. Get this board back in its spot. See it fighting me. Okay, let's lay this like this. Alright. Alright, 1, 2, 3, here it goes. Cycling through. Now look at all the lights. Now they're going to the very top. So the weak capacitor is what's causing those lights not to go all the way to the top. So we had to, we'll install this capacitor. We're going to go from a 16 microfarad up to a 20. So actually it's going to go from about 3 joule probably to about a 4.5, 5 joule basically by going up a little bit. So this one's going. We'll just use that capacitor. What we'll do is keep it in place. We'll use a combination of probably double-sided foam, real good 3M sticky stuff, and some real good sticky glue that'll harden like a rock in about a day. So we'll get this capacitor out. Come on. Once we can, I've got little hold down areas. Just charge this capacitor real quick. Let's unplug this wire here. Feed it underneath like that. Let's see if we can. Got these little spots for zip ties to slide through. I want these zip ties that I've got here. I want their like built-in hold-down area. Let me see if this is will fit. Alright, yep, will fit. So I'm going to have to use no glue. We'll just use these black zip ties. See if I can get to center it to where both zip ties will catch. Come on. Come on, we're catching on. Let's get started. And then we'll. Oh, God. We might not be able to get both to hold. Might just have to use one. It still wants that ain't gonna work. Let's see if we can slide it back. Get it into the other one at the same time. Two of them to hold, maybe to hold better. It's because it's not round and the zip ties can't form, you know, they don't bend to a square right angle. You know, this is a little taller. Probably get it to hold in there better with two of them. Well, ain't gonna work. Come on. God, these snips about had it. They're not very strong. Cutting them, but like, okay. Well, let's get out the double-sided foam. I'm actually going to put two of them on there. Come on. on tape, or this backing. There. And then I'm going to run a bead glue type stuff right along the back side there. Okay. Give that 24 hours of cure. And lock it on there where it ain't going to move. Not anytime soon anyways. Okay, so now we'll take this wire, go underneath, back over to the board. And we'll come on. Nope, not in there quite right yet. Oh, God. Oh, man. Okay. I think it's in there right. We'll take this wire, just tuck it down like that. Let's see, transformer will get it slid where it needs to go. It's kind of slid out of place a little bit. Should be good. Once that cures, this thing will be ready to go. Only other thing I want to add is I want to put some dielectric grease on this little spot there, because these are pretty prone for corrosion. So I'll put it on the lead here. And then we'll shove it in there and just kind of twist it back and forth. Now that should coat things pretty good. That'll slow down because those are pretty prone for oxidation. Alright, let's turn it back on, make sure it still fires. See the lights. Yep, all the lights are lighting up. There we go. So now it's fixed. And it's got a bigger capacitor in there. So now they'll have even a little bit more joules than they did before. Now I'll put the case back on, put the screws back in it. And I'll set it off to the side, let that glue stuff cure. It turned solid as a rock. And it ain't gonna come, that capacitor ain't gonna come loose anytime soon. After that stuff cures, it basically turns to a rock. So, well, thanks for watching me work on one. It would have been a lot easier just to put a new board in it. And new capacitor, but we were able to fix the board, luckily. Say it cost them a bunch of money. All right, well, there we go. We'll shut it down and move on to another one. Now I'm missing their washer and their nut there, but I guess they got it at their place there. Well, thanks for checking out our channel. Until next time, see you later on. Have a good rest of your day.